Financial Modeling, Topic 4, Portfolio Optimization, Section 2, Constructing the capital allocation line, which is a line that combines a risk-free asset and an envelope portfolio. So, when you combine a risk-free asset and a risky asset, that combined portfolio mean is the weighted average mean, so simply the sum product, and the volatility, however, is simply the weight in the risky asset times the volatility of the risky asset. You don't have to worry about the risk-free volatility because it's zero. So when I combine a risky asset plus a risk-free asset, the standard deviation of that portfolio is simply the weight in the risky times the volatility of the risky. Also, when you combine those assets, combinations of those assets will simply plot along a straight line because it will not bow like an envelope bows due to diversification. Now, the trick is trying to find one special portfolio that I want to combine with my set of envelope portfolios. So we've already calculated our envelope portfolios and we've graphed them. Now I want to combine one of these assets, one of these risky assets on this line, with a risk-free rate. Now I could choose this one here, that first portfolio. Combinations of this first risky portfolio and the risk-free asset would plot along a straight line. But I can do better than that. What if I combine it with this asset? Notice if I combine it with the second portfolio, that would be much better. I'd rather be on a line that's up here than down here. But I can do better than that. What if I can just find a portfolio that one plots the risk-free asset and one of these risky assets is a tangency to the envelope. Now this becomes the optimal portfolio to hold in addition to risk-free assets. Also notice I cannot get that line to go past this point right here. This would be a point in which I would say borrow and leverage this portfolio. That's in a later topic. So I want to try to find an envelope portfolio that has a tangency to a line that extends from the risk-free rate. Now let's think about how I'm going to do that. What I'm going to do is I'm going to set up a formula that tries to find the slope of this line, and I want to maximize it using solver. Now the slope of this line is going to be the return of a portfolio minus the risk-free rate over the standard deviation of a portfolio. That is also called the Sharpe Ratio. So let's go to our spreadsheet. Notice I have a spot here called Sharpe. I'm going to put in there the return of the portfolio, which is B5, minus, I have a range here, a range name here of risk-free rate, so I can just say RF, which will be that 2%, divided by the volatility of the portfolio, vol. Now that's my Sharpe ratio. Now when I go ahead and run solver, I'm going to maximize Sharpe by changing the three weights. I want to eliminate my constraint on mean because I want to find any combination of risk and return that maximizes the Sharpe. I'll hit solve. There's the portfolio there, 76% SPY and 24% EMA. Gives me this portfolio volatility and mean. I'm going to go ahead and copy that portfolio. I'm going to paste it right here, Alt-HVV. So I'm going to call that the optimal risky portfolio. That's the portfolio that combines the risky asset, which plots along this envelope, and a risk-free rate of return. Now I'm going to add this risk-free rate to my graph. So I'm going to select my data, right-click, select data. I'm going to add RF as a name with a volatility of 0 and a standard deviation of 2. All right, so notice there is my RF. Now I'm just going to draw here for a second. Whoops. I'm going to just insert a line. Well, got to find those lines. Oh, there it is under shapes. So notice I'm just going to draw this for a few minutes here. So what I'm really trying to do is this is my risk-free rate of return, 2%. And what I want to do is I want to combine it with one of these 6 portfolios. Actually, any portfolio that would plot along this envelope. Now notice I wouldn't want to combine it with this asset because this one's better. Any movement upwards is going to be better. That's a higher expected return. I could do better by combining it with this one, but what I really want to do is I want to find this portfolio right here that's an envelope, that's a tangency to the envelope. That portfolio maximizes the slope of this line. The slope of this line is the Sharpe. So this is the portfolio. It must be right around here. That's the tangency of the line extending from RF. Now what I'm going to do is I'm going to add this portfolio here and combine it with RF to show a line on this graph. How I do that is I'm going to again go to my data, right click, select data, add, I'm going to call it the CAL, which is a capital allocation line, put in 2 volatilities as X, plotting the 16% optimal risky portfolio and the risk-free volatility of 0, and then put in the 2 expected returns. And there it is. That's my capital allocation line. Now, if I want a portfolio that has less volatility than, say, this amount here, what I could do, I could combine this asset right here, or this portfolio, which is 76% SPY and 24% EMA. I can combine that portfolio with this risk-free asset, say a treasury that provides a 2% return, and I can plot anywhere along this line. So if I want a portfolio that has, say, roughly this level of volatility, say 10%, I would combine, looks like about 50% of the risk-free asset and roughly 50% of this optimal risky portfolio, and I could plot on a line that sits at around here. And if I increase my weight to the risk-free asset, I start moving my combined portfolio down towards the risk-free rate. As I start decreasing my weight in the risk-free asset while increasing my weight in that optimal risky portfolio, I start plotting along this point. So this becomes my capital allocation line, how I allocate capital between the risk-free asset and the optimal risky portfolio. So in this section, we constructed the capital allocation line and talked about combining the risk-free asset and that optimal envelope portfolio. And the next topic, we'll construct an optimal capital allocation line if we have borrowing.